Okay, you have two masses colliding. So during the interaction, they will exert forces on each other. But remember Newton's third law. So these two forces must be equal but opposite. Since they act on each other for the same duration of time, it also means that the impulses are equal but opposite. And remember, the impulse can be equated to the change in momentum. So that means the change in momentum of these two masses are also equal but opposite. And that's why the total momentum of these two balls is conserved, because whatever momentum change that happens to one of them happens to the other one in the opposite direction. So the total change in momentum is zero. So what is the total momentum? So before the collision, if we take rightward to be positive, then we have 2 kilogram times a positive 4 plus 3 kilogram times a negative 6, which gives us 8 minus 18, negative 10 kilogram meter per second. So the total initial momentum was not 0, it was negative 10. It was a leftward momentum. So during the collision, at any instant in time, the total momentum must always add up to negative 10 kilogram meter per second. So let's suppose that one of them come to rest first. I think it's obvious that this one will come to rest first. So when this one is at rest, the momentum of this guy is 0. Alright? But the total momentum must remain as negative 10. So this guy cannot be at rest. If this guy is also at rest, then the total momentum is really 0, and that will not be equal to negative 10. So in fact, when this guy is at rest, its momentum is 0. This guy's momentum must be 10 kilogram meter per second towards the left. So its speed should be 10 divided by 3. Alright? So it's about momentum, it's not about mass, it's not about speed, and definitely the forces, the impulses, and the change in momentum experienced by these two forces are always equal but opposite. Okay, ta-ta!